Section 1, Chapter 2, Lesson 4, 4 of 5, so dividing radicals, Part 1. So this is where we have to work on rationalizing. A lot of times when we're doing radicals, we don't want radicals as a denominator. So that's the focus in this chapter, or these sections, is to get the radicals off the denominator. You still have the ability to divide radicals, just like we can multiply them, though. In terms of the same index, you can divide the radicands. So that still is possible. So square root of a over b is the same thing as square root a over square root b, just signifying you can divide the radicands for the same index. Okay, and then just like multiplication, you can divide the m and the n, divide the radicands, just like we multiplied the m, and then we multiplied the radicands. So same rules. So divide numerical coefficients by numerical coefficients, divide radicand by radicand, and simplify into mixed radical form. So before, we're not going to do rationalizing yet. We have some kind of straightforward ones. So root 30 over root 6, guys, is simply root 5. 30 divided by 6. Okay. So b, we're at the same index, so we're okay. 8 divided by 2 is 4. 21 divided by 3, cube root 7. Okay, 15 over 10 is simplified to 3 over 2. Then we have radical 48 divided by 6 is 8. And we can break the 8 down, however. 4 times 2. Pull the 4 out as a 2, which cancels this 2 here. 3 cube root 2 is what's left when you simplify that one. And this one's just testing, like, trusting your stuff. So 4 over 12 is 1/3. Root AB over root A, the A's cancel. You have just root B. So it's simply root B over 3. So you can write it as 1/3 root B or root B over 3. Those are the same things. Okay?
Does it matter which one you put?
Of those two, no. No. They mean the same. Yep. Okay, in some cases, converting a radical into simplest and mixed radical form before dividing will make the calculation easier. So what they're saying is that you can break down the stuff here first, because 54 doesn't go into 8, or 8 doesn't go into 54, and so that doesn't really help me. So what happens if I break this down? Well, 54 breaks down to 9 times 6, and 8 is 4 times 2. So 9 comes out as a 3, so it's 12 root 6. Okay, 12 root 6, and then pull this out is 6 root 2. And see, now I can divide this now. 12 divided by 6 is 2. Root 6 over root 2 is root 3. So 2 root 3 is where we get with that one. So we simplified first to get something that possibly could divide better. Okay, what are some squares that go into 126? Not very common. No, 64 is 128. 9 and 14. Okay, good, Sophia. 9 and 14. The 9 comes out as a 3. So we're looking at 24 root 14 for that top one. 112 is 16 and 7. The 16 comes out as a 4. And so we are at 4 root 7. And so you can see that kind of smoothed out as well. 24 divided by 4 for 6. 14 divided by radical 7 is radical 2. 6 root 2 is where we end with that one. Okay, cube roots, again, those are a little more difficult ones to remember. 162 is 27 times 4. Oh, sorry, 6. Oh, yeah, 162, not 1, sorry. Times 6. Okay, and then the 27 comes out as a 3, so then we're looking at 30 cube root 6. Okay, and then we have 128 is 64 times 2. 64 is a perfect cube from 4. So that becomes 80 cube root 2. And so 30 over 80 can only be 3/8. That's all we can do. And then cube root 6 over cube root 2 is cube root 3. So again, that can sit on top or it can sit on the side like that. Both are okay. So that's all for that one. Okay. One more and then we kind of dip into rationalizing. Okay. So with these ones, hopefully you remember your rules for fractions, is that this root 6 hits everything with division. So all 3 pieces are going to be divided by root 6. So 24 over root 6, that's root 4, plus 48 over root 6, that's root 12, or no, root 8, sorry. And 108 divided by root 6 is 18. Yeah, thanks. Root 18. And we're going to break those down now. Root 4 we don't have to break down. That's just 2. Root 8 is 4 times 2 for 2 root 2. And 18 is 9 times 2 for minus 3 root 2. And then from our lesson 2, with adding and subtracting, we can do the 2 root 2 and the negative 3 root 2. So your final answer here is 2 minus root 2. So it's 2 root 2 minus 3 root 2. They're both root 2, so it's 2 minus 3, which is negative 1. That's like a negative 1 right there. Yep. Okay, anything else there? So that's division. So division is very similar to multiplication. Okay, same properties. All right, now we're going to get to the rationalizing piece. And then tomorrow we'll hit the hard conjugate piece. All right, so rationalize the denominator. So usually answers are written in the simplest form. 1/6 plus 1/3 is 3/6, which simplifies to 1/2. With division of radicals, we want simplest form to not have radicals on the bottom. So the process of eliminating the radical denominator is called rationalizing the denominator. And so what we want to do is, just like when you had a common denominator of the fraction, you times the top and bottom number are the same thing. We're going to do that here as well. It's that same idea. So I'll just kind of do the examples here. So if I want 1 over root 13 to be rationalized, I go root 13, root 13. Why am I going to do that? Because what's root 13 times root 13? It's just 13. And so now the radical is gone. The top is your root 13. So this is your simplest form. See how the radical is no longer on the bottom? That's the purpose. Okay? So Max, what would you try for B? What would you multiply the top and bottom? Radical 2. So I go radical 2, radical 2. Root 2 times root 2 is just 2. Root 2 times root 5 is root 10. That's it. Okay? Now for C, the negative's not relevant because that doesn't really affect the radical or not. So you can just do root 6. If you want to do negative root 6, that's okay. It's not going to be wrong. But just you don't need to. Okay, root 6 gives me root 12 over negative 6. Root 12 breaks down to 4 times 3, which gives me 2 root 3 over negative 6. 2 over negative 6 reduces to negative 1/3. And so you could write it like that in simplest form. You don't have to have the 1 there. I just wrote there so you can see the negative 1/3. I reduced 2 over 6 to 1/3 if I lost you. Okay. So for D, we can simplify the 20 now, or we can go ahead and rationalize. It doesn't matter which. Maybe I'll do it just rationalize now. So if I rationalize now, I'd get root 3. I get root 60 over 3. And I need to break down 60. What's 60 break down to? It's perfect squares. 4 and 15. So we go 4 and 15. 4 comes out as a 2, so it's 2 root 15 over 3 is your best case there for simplifying that. Now again, we're just simplifying, right? So the beginning calculation, if you calculate that, and your end calculation should again be the same decimal if you want to check your answers. If you put root 13 over 3 in your 13 over your calculator, you should get the same thing as 1 over root 13 by a decimal. Okay, we're not changing the values. Okay, we just got a couple more here. So this one, root 7 to top and bottom. Okay, so this one gets interesting because 7 root 7 is on top. And then we have 3 times 7 on bottom. You can multiply, it's fine, but I just did that because, see, I can see the 7's cancel. And so it's just simply root 7 over 3. Or 1/3 root 7, whichever. Okay. So root 18 over root 5. So we have root 18 over root 5. So we're going to break down the root 18 to the 9 times 2, which is 3 root 2, just to make things smaller this time. And now I'm going to do the root 5 part. Could have done that earlier. But the biggest thing people get confused here is what to do now. Here you need to write the radical on top and bottom. So root 5 to top and bottom now will be at 3 root 10 over 5, which is the final answer. Five times 3. Where at?
Well, like, because you just times 5 by 3 to get on top.
5 by 3. Why would you times it by 3? Sorry. Like what?
5 times the 3 or
This one?
Yeah.
5 times 3. I'm trying to remember what you're saying.
That way that's just all on top.
Yeah, so you can't do that because if you times 5 here, like that's going to make 25 down here. You know, so I see what you're saying. You're trying to get all off the bottom. You can't quite do that. Yeah. Because whatever you do at the bottom, you have to do the top. Okay, so 3 root 12 over root 72. So root 72, let's just break these two down real quick. That's 36 times 2. And this is 4 times 3. So 4 comes out as a 2 on top. So this 2 hits the 3 there. So 6 root 3 is my new top. 36 comes out as 6 root 2. So my 6's cancel, so that's nice. So I only have to rationalize root 3 over 2, which gives you root 6 over 2. So that's that one. Okay, and then we're just going to do one last one here. All right, any questions? And just you know, disclaimer is that obviously, guys, that I pull the perfect square stuff out pretty obviously quickly because I've been doing this a long time, and so don't be frustrated if this part takes you a little bit longer to find the 36 and the 4. You'll kind of get that over time, so don't beat yourself over not going as quick. Okay, these can be messy. Okay, all right. So they're going to do here is they're just going to kind of show you a couple of things to consider. They're going to rationalize the denominator first, and then we're going to divide the numerator first. So we're going to use division from our first page, and then we're going to rationalize. So let's rationalize first. This time I won't simplify the top. It's fine. I'm going to times root 2 top and bottom. So if I times top and bottom, it does hit both things here. So it's going to be 3 root 36 minus root 24 all over 2 if I rationalize. We know that 36 is just 6, so it's 3 times a 6 now. We know 24 breaks down to 4 times 6. So So we're here. And then we're here, and there's one more step, but I'll wait. So the last step that we're going to do is, that you're writing that down, is we're going to divide 2 to top and bottom, because 18 has a 2 in common and 2 has a 2 in common. So we have 18 divided by 2 is 9. 2's cancel, so minus root 6. That's your answer there. Okay, and then I'm just going to show you one last one here. 3 root 18 minus root 12, and they said divide the root 2 first. By a rule of division, it goes here and here. 18 divided by 2 is 9, so 3 root 9's here. 12 divided by 2 is root 6. Root 9 is 3. And so we get the same answer as we expected, 9 root 6. And so that just shows you that you might as well check to see you can do division first, because division's easier than rationalizing. Rationalizing is a little bit uglier. Okay? All right.